We've already seen how we can calculate the volt drop on a circuit where we don't actually know the load and we've used the rating of the protective device as our current. Of course, that's not always as accurate as we'd like to be. So on a circuit where we know the load, the actual load, we can use a slightly different method. On this test sheet here, we can see we've got a water heater, which is protected by a 20 amp Type B circuit breaker. The line conductor is 2.5, the CPC is 1.5, and my measured R1 and R2 value is 0.86. So if we now carry out the calculation using the values that we've got, our R1 and R2 value is 0.86. The load for the water heater we know is a 3 kilowatt water heater, so it's going to be 13 amps. So we can use 13 amps in this instance. Multiplied by the 1.2 for our temperature correction, that will give us a value of 13.41 volts. Now again, we know that that's too high for our circuit. We're only allowed a value of 11.5. But again, we also know that this R1 and R2 value is made up of a 2.5 line conductor and a 1.5 CPC. So using the process that we used before, we can calculate the resistance of our line conductor only. Simple process. The line conductor size divided by the line conductor size plus the CPC size, and times our R1 and R2 value, which is 0.86. The answer to that is 0.62, which is in ohms, of course. So we now know that this is the resistance of our CPC, this is the resistance of our line and CPC. Of course, I really need to know the resistance of my line conductor, and as this is the resistance of line and CPC, all I need to do is take this away from that, which will give me the answer I'm looking for. So 0.86 minus 0.62 equals 0.24. 0.24 is the resistance of my line conductor. We know that in the circuit we have a line conductor and a neutral conductor. To calculate volt drop, I need the resistance of both of those together. All I need to do is just simply double that. 0.24 plus 0.24 equals 0.48. This value now is the value I can use in my calculation to calculate volt drop for this circuit, and it's going to give me a very accurate calculation as well. So 0.48 times the current rating of the heater times 1.2, which is the value which I use for my temperature correction, will give me a value of 7.48, which is in fact the volt drop for that circuit when it's fully loaded.